Hi all, welcome to Anjan GCP Data Engineering. So there are some requests coming like to show how to process nested and repeated data using Apache Beam, right? So in this video, what we will do, we'll try to read some JSON data which is available in a Google Cloud storage, and we'll try to process the data by nesting it using our Apache Beam pipeline, and we'll try to write the transform data into a BigQuery, right? So as part of this demo, I'm going to use Python SDK along with the Beam SQL features. Okay, let us quickly go to our demo slide. This is what I'm going to do. First of all, I have already placed some JSON files into a Google Cloud Storage bucket. So we'll read that data into our Apache Beam pipeline. Okay, so what we'll do, we'll test the pipeline using Apache Beam direct runner. So we'll do that in using our Cloud Shell environment. So in the Cloud Shell environment, I've already installed all the Apache Beam related packages. So what I'll do, I'll try to run each and every step, and I'll try to show how the data is being processed at each and every stage. Okay, so once we are okay, we are satisfied with the output, our expected output, and then what we'll do, we'll try to run that pipeline on a Google Cloud Dataflow environment, right? So then that pipeline will again process the data in a distributed environment, and we'll try to insert that transform data into Google Cloud BigQuery. So this is what we are going to do. So, and also many of you already asking to share the sample codes or codes which have been used as part of various demos, right? Especially Apache Beam pipelines, right? So I have a different plans to share that code in future. So basically I'm looking out to, if I see we have some significant subscriber base, definitely I will share that code, right? I'm working on that already, but meanwhile what I'll try to do, I'll try to share this code, right? So I will see how I can share that code with you. Okay, so but thank you very much for your interest and support which you have been providing. So now let us go to the demo quickly. Okay, so this is my storage bucket. Okay, so I have placed some sample files. Basically it is a JSON file where it is having some sample Indian Premier League cricket match stats. Okay, so it look like this. Okay, so it is like this, it is in a JSON format. So we have a player name and age and the team, and also its performance. So performance include everything. Now it is in it's a record type. Basically when you directly try to load this data into BigQuery using our JSON file, right? So it will load the data into a table where you will have this nested columns. So each player has multiple records with the match stats, like what is the match number and runs scored and wickets, catches, or something like that. So it's basically it is a nested and repeated data, right? Okay, and also it's a his previous 3 batting averages also captured, right? So what we'll do, we'll try to read this data. Now what I'm trying to calculate by using this data, simple. What I'll do, so I'll basically read this data and I'll unnest it using my Python logic, right? And then we will have unnested rows. Okay, then what we'll try to do, we'll try to sum up all the runs scored by each player, and also we'll sum up wickets taken by each player, and we'll try to find the maximum runs scored by a player and also maximum wickets taken by a player, and we'll try to also uh, basically append this information to that stats, like what is the player name and age and the team, maximum runs scored and maximum wickets taken. So we'll basically derive these stats and we'll try to insert those values into a BigQuery table. So this is what I'm going to do with this data. Okay, now let us go to the pipeline directly, right? So this is a pipeline which is doing that particular stuff. Okay, so here what I'm trying to do. So anyway, the first step or first stage is importing the required module. In the second step, we need to define our pipeline options programmatically. So we can define our pipeline options using different methods. I already discussed in my previous video. We have defined our pipeline options using CLI commands, but in this particular demo I am trying to define my pipeline programmatically. We can define our pipeline options like this, where so saving main session as a true. Right now I would like to test it, right, in my using my direct runner. That's why I'm using direct runner. Once I run this pipeline in a data flow, I'll just use this particular option where runner equal to data flow, and the project, the temp location and the GCS bucket which will be used by our Apache Beam pipeline, and the region where I'm going to run this pipeline. Okay, and now this is our Purdue class. I'll explain, right? So here in this pipeline I'm also using Beam SQL features, right, and along with our Python logic. Okay, now what I'll do, I'll try to execute this pipeline my direct runner in Cloud Shell, and we'll try to see how this output coming from each stage or each step, right? Okay, now I've commented everything. So I'll try to run this pipeline in Cloud Shell. So the first step, I'll read the data which is available in the bucket into a P collection, right? So now I'll try to pin that P collection using this map printer. Okay, this function. Now we'll see how it look like. Okay, it will look like this only, same thing. So let us try to run this pipeline, right, using direct run. Just observe, I am not basically passing any arguments to the script because I've already defined all my pipeline options over here. I don't need to again explicitly define any parameters or pass any parameters along with the script. Okay, now let us try to run. At direct runner, you can see as it is getting printed, same thing like this, right? Now what we have to do, we have to unnest this. For example, let's say this player has 3 records. Every player almost has 3 records, right, with the 1 record per match, right? Now I have to unnest it, right? So now this will flatten it. So now this will become 15 rows. Now we have 5 rows, so each row will have nested 3 more rows. If I flatten it or unpack it or unnest it, then 1 row will become 3 rows. So like that it will become 15 rows, right? That is what I am trying to do using this particular option, Purdue function, right, Purdue class, right? So what it will do, it will just read this. It's a basically when you read this data into a P collection, it is a collection of strings. Now each line is a string. Now what I'll do, I'll just read that into a Purdue. This Purdue will convert that dictionary notated format into dictionary itself by using this JSON loads function. It's a Python method or library available where if you pass string notated dictionary into this function, then it will convert that into a dictionary. That is what I'm trying to do, right? And then I'm trying to basically fetch required fields from this string, right? So what it will do, it will try to fetch first 3 columns like player name, age and team, right? And also I am also appending this previous 3 batting averages stats, and then I'm unpacking these 3 rows which are nested inside it, these 3 rows, right? So that it will become 1 row will become 3 rows. So it's basically a flattening of the data, right, using this for loop. Okay, right? Then it will look like this. Let me print this. So how it look like? Okay, again run this. right? See, now we have 15 rows. If you see player information, age, team, and previous 3 batting averages, you can see. So this particular player has 3 records nested. Now it has become 3 rows, right? This is the set, next set, next set, next set, something like this, right? Almost 15 records. Okay, now in the next step, what we'll do, we need to filter out few records, because if you see, especially I would like to find maximum runs scored by a player and also maximum wickets taken by a player. If you see in the data, so most of the data has been populated with numbers. If you see, there are few rows where if that particular player is not batted in that particular match, so it is mentioned as not batted. If particular player is not taken any wicket, so it has been mentioned as not bowled. So I don't want these rows to come into my P collection. I would like to filter out these rows, because if I do a sum, right, so since it is in a string format, we can't sum up, right? We'll throw an error. In order to avoid that, I need to filter these records wherever we have a wickets equal to not bowled and also run scored equal to not batted, right? That is what I'm doing with this particular transformation. I'm just applying back to back filter transformation on this P collection coming from this particular transformation. Let us try to print how this data look like. Okay, now you can see those records have been filtered out. We have only now limited records, right? So now in the next step, again, now this is in a dictionary, sorry, in a string format, right? So now I would like to again convert into a dictionary format, right? Whenever this particular transformation is outputting this information, this is in a string format. Now I'll have to convert that into a dictionary format, right? So that is what I'm again using this JSON loads with mapper lambda. Now this will convert this particular row, each line into a dictionary format, right? So let us try to print how it look like. It would look like same thing, there will not be any much difference, but the first one is in a string format, the next one is in a dictionary format. Okay, now you can see, now each line has been converted into a dictionary format. Now I would like to use our Beam SQL to perform these transformation, because we need to aggregate the data, we need to sum up the runs scored and we need to sum up the wickets taken, and right. So for that I would like to use SQL. This is a SQL I'm trying to use. So by using Beam SQL, so you have an option where you can try to query P collection using our standard SQL, right? This is supported by our Apache Beam SQL, right? What I'm trying to do, so I'm trying to group by player, age, team, and this particular batting average, and then summing up runs scored and wickets taken. Okay, that is what I'm going to perform using this particular transformation over here, right? So if you see, before performing this particular transformation, first of all you need to convert this data into beam row format, otherwise you cannot perform that SQL operation on top of the data which is coming out of this P collection. So for that we have a transformation available. So this is a transformation, so where we are using beam row on the map, we are trying to define a schema, right? So for the beam row, where player name equal to, so we are just reading this dictionary value by using its key, so converting into string like that, age, team, and match number, run scored, wicket, and this previous 3 batting averages, which is also string format. So it doesn't support any list over here, but right now it is supporting string, that's why I'm using string format. If you don't specify this conversion over here, it is throwing an error actually, right? So what it will do, right? So whenever you are trying to use Beam SQL internally, it is using Java SDK to perform all these transformations, right? You need to define the schema, and you need to even mention the type also of each column. So with this syntax, I'm doing that. Now you can see how this beam row look like. Okay, let us try to print this output. See, it look like this. You can see row, you can see each row has been mentioned here like this. Now you can perform your SQL transformation using our SQL transform, which is available through Beam abstraction. Okay, so this is the query I'm using, just grouping and summing scores and wickets, right? Let us run how this output look like. Basically this is a dialect, so it supports JSQL for BigQuery, because we are going to write this output data into BigQuery. That's why we are using JSQL. We do have different dialects also, like so you can go to the documentation, but for BigQuery usually JSQL is recommended, right? It takes some time because it has to download some Java related stuff, and then it will display that output. See, so you can see now it is still in a beam row format. You can see now that aggregation is performed on top of those rows. You can see this is the summed up, right, scores, run scores, and also wickets, right? So I hope you are clear, right? Now let us go to our pipeline again. Now in order to write this data into my BigQuery, again I'll have to convert that into a dictionary format, right? So that is where BigQuery will support to write data into BigQuery table. So that's why I'm using this particular transformation. So where we have this particular method as ticked, directly you can use, right, which is available through this row function, right? Then it will be converted into a dictionary format. Now let us print this output again, how it look like. See, now you can see each row has been converted into dictionary format, right? So now directly you can write this data into BigQuery, but the problem is if you see this particular column, previous 3 IPL batting average, so this is in a string format, right? We have converted this into a string format here actually, right here, but I would like to write this data into a nested format into a BigQuery table. For that again I'll have to convert back into a list format, right? So that is why what I'll do, I am trying to use one more transformation, user defined transformation. I'm using this function where I'll try to read that string formatted list and convert into a list using this particular function. So simply it will take that dictionary, so it will just update that particular key value. So it will use this Python library AS literal evaluation. So it will just convert that string formatted list into a list, right? So this is in quoted, right? It's a string. Now this will be converted into list itself. Now we'll try to print that output, how it look like, so that you can understand why I'm doing this particular transformation, right? So let me again run this pipeline. So now it has been converted into list. Earlier it was enclosed in a single quotes. Now it has been converted into list. If you go to our previous output, here it was in quotes. Now it has been converted into list. Now I can write this data into BigQuery. How it will write into a table like, so this will be a columns, but this particular column array basically, right? So it is a repeated, it will be written as a repeated field, not nested, a repeated field. If it is a record, it is a nested, but it is a array, it's a repeated field. Now let us try to write this data into a BigQuery. So now let us go to our pipeline. So By using direct runner also I can write this data into BigQuery, but now what I'll do, I will try to launch this pipeline into Dataflow directly. I don't want to run this on direct runner. Let us uncomment this. Now we have this series of transformation. So we have resultant data into this particular P collection. Now we are using that P collection and writing the data into BigQuery. If you see, this will be written into this particular table. This is the data set and project. Now what I am specifying, anyway it is in dictionary format. Dictionary or JSON are already coming with the schema defined inside it, right? If you see here, so already schema is defined, right? Player name and the value, key value pair, that means, right? That's why I don't want to explicitly mention my schema over here. Instead, I'm just asking this transformation to detect schema automatically. That's where I have mentioned like this. Now it will create the table if it is not already available or exist. Then if it is already available, it will truncate the data and try to insert the data into that particular table, right? So in order to run this pipeline and data flow, since we are already using direct runner, let me comment this and uncomment this, right? Just change the configuration or parameters, right? Now let us try to run this pipeline again in the Cloud Shell. This will launch a Dataflow program, a pipeline, batch pipeline, okay? Yeah, it will take some time. Now it is running this pipeline and a Dataflow runner. So now we should see some batch program running over here. Now you can see this job is launched into Dataflow. It took some time to install some internal packages. Right now let us go to our Dataflow jobs page. Just refresh it. Now you can see there is some batch job launched. Just click on this. You can see now this job is running. It will take 4 to 5 minutes to complete actually. So once this job is completed, we can see our output results into BigQuery, this data set. Right now we don't have any tables created. Once that job runs successfully, you can see that particular table over here, okay? So let us wait till that time. You can also monitor this job logs over here. Just click on show so that it will show you the logs. Whatever the logs or information displayed over here, you can same thing you can see over here, right? It's spinned up one worker, starting one worker, it's running on one worker now. Basically, if your workload is very huge, it automatically scale up its workers up to hundreds, thousands, right? And there is an option to even restrict number of workers to be used by any data flow job also by setting up parameters, required parameters, number of workers, right? But anyway our workload is a bit small or smaller for demo purpose. That's why I haven't mentioned any workers parameters. So it anyway it's using one worker only for our workload. Okay, so this is how you can use this stack driver logging or logging module to monitor your job. Okay, each of this label coming from this particular label, right over here, whatever the label we are mentioning in the pipeline over here, so this will be displayed over here from GCS Spark JSON filter required data, something filter, something like that. It will display each label, right, coming from here. So that's why you have to be very careful while even defining the label, right? You can't have same label name for two different transformations. It will throw an error. It won't allow duplicate labels, right? So just remember, while coding, try to use some meaningful labels for each and every transformations. Okay, we are left with one stage, last stage. Now done, it has returned results into BigQuery. Now let us quickly go to the BigQuery. So just refresh our page. right? Now you can see this table has been created. You can see the schema of the table, right? So there we have mentioned the autodidact schema. Based on the data itself, it has defined its schema. See, this particular column, it's a float and repeated, it's an array. Now let us try to preview the data. You can see this is an array, it's a repeated field, right? So we do have the player name, age, and the maximum run scored, so, and also maximum wickets taken, right? So this is how you can process the nested and repeated data using our Apache Beam pipeline. It is simple. Basically I've used the Python and also Beam SQL. So there are other options also. It's completely depending on your requirement. Okay, so in the next video, so it's going to be on the same concept, where we are trying to process few logs coming from our stack driver logging API in the Google Cloud platform. So and then we'll process those logs using our Dataflow pipeline, and we'll see, right? So how to create those basically log syncs. What are the different options we have over there? Okay, thank you very much for watching this video. So I will try to provide the code which has been used as part of this demo. Maybe just I'll try to provide that link with the video description, right? So just keep an eye on this video. Thank you very much.